Hey, what's up? Let's do some math today. So in this video, we're going to talk about graphing linear functions in standard form. So standard form is just another way of a linear function could be presented to you. And what it is ax plus by is equal to c. Now, typically, a, b, and c are all whole numbers, and a is not negative. Now, we're not going to be limited to that sort of definition of standard form because sometimes you're going to see it in different looks. And the goal here in this unit is just to take a look at, no matter how I'm given the equation, how can I find the line and how can I do it as easily as possible? And that gets us to how this whole thing works. It works by finding intercepts. Now that word intercepts are where the graph crosses the x or y axis. And so if we're talking about the x-intercept, what's going to happen is that's where it's going to be crossing the x-axis. So let's just say it crosses it like right there. We're going to have some x value and 0 there. So that's on the x-axis. The y-intercept is going to be the opposite, 0, comma, and then some y value. Like this would be 0, comma, -4. We're going to try to find these because if we have 2 points, that's all we need to make a line. And then usually like a straight edge and try to make a good straight line. Really hard to do that on this. I'll try again, maybe a little bit better here. No, still kind of difficult there. But anyways, if you have paper and ruler, then it's pretty easy to draw, once you have those 2 points, to draw a line that goes right through them. Now, the way it works is we're going to make a table, okay? So we're going to go x, comma, y, and I'm going to put a little dashed line here for a reason, and I'll explain in a second. You go 0, comma, 0. Or sorry, not comma, 0 and 0. We want to put those in 2 separate columns. So that's why I kind of have this little dashed line here to show us that those are 2 separate things. What we're going to do is we'll then plug in this 0 into our function, and we're going to get some sort of number right here. And what this is our y-intercept. We plot that on the coordinate plane. We then repeat the process for letting y equal 0, and we'll again get another number, and this time we'll get the x-intercept, and then we're able to connect those intercept. That's how I spell that. So here, intercept. There we go. And then we're able to connect those 2 points, and we have formed a graph. So let's take a look at some examples. All right, so let's start off with this red line right here. What I'm going to do is make a nice little XY table, and then I go 0 here, 0 there. Now, when I'm letting x equal 0, it's going to get rid of my x term completely. So I'll show you the process here. It'll be 5 times 0 minus 2y is equal to 20. 5 times 0, nothing, disappears. So I'm looking at negative 2y is equal to 20. Divide both sides by negative 2, and then I get y is equal to negative 10. So negative 10. All right, now I'm going to clean this area up. I'm going to repeat the process, but with letting y equal 0. So I'll have 5x is equal to, oops, not 5y, one sec here, sorry. All right, 5x minus 2 times 0 is equal to 20. Again, this will completely disappear because 0 times anything is just 0, so it's not even there. And then I have 5, divide both sides by 5, x equals 4. Take this, put it right there. Oops, not 5, 4. There we go. So now I have 2 points, 0, negative 10, which is right here, and 4, comma 0, which is right there. I connect them, and I'm good to go. So let's try to make this nice and neat. Yeah, try that one more time. Last time. There we go. Okay, and again, should have arrows pointing that way, and we have what the graph looks like. All right, now let's do some slightly different examples, and let's see if we can maybe pick up the pace a little bit here. So again, first step is we're going to make an XY table, 0, 0, in two different rows. And so when x is 0, this whole 6x part goes away. So I'm essentially looking at 3y is equal to negative 12. Divide both sides by 3, y equals negative 4. And then when I let y equal 0, I have negative 6x equals negative 12. So x would be 2. All right, so go to my graph. Let's see here. So 0, negative 4 would be right there. And then 2, 0 is right there. Come on over, draw a nice straightish line. Boom, boom. Look at that. I've drawn the line for this. So again, the goal with standard form, I'll often call this the intercept method. So I should actually write that down here. I like to call this the intercept method because what we're doing is we're finding the graph by finding intercepts. So method, boom. All right, finally, let's do the blue one. Kind of show you a little bit of a curveball here. Not much of a curveball, but nonetheless. X and Y, and so 0, 0. When x is 0, the 8x is gone, so we're looking at 4y is equal to 8. So 4y equals 8, y would be 2. And here, it might just look a little bit weird when we put in 0 for y, but we're looking at 8x is equal to 8, we'll get 1. Now, occasionally, you might run into a case where you get fractions, and that's totally fine. So if that was the case, you would just go to a fraction on either the x or y axis and plot the point there. So anyways, let's go with 0, 2, right, as our y-intercept. So 0, 2 goes right there. And then 1, 0 is right there. So 1, 0. And then we graph that. Boom, draw a line, put some arrows on it, and there we go. So again, what we're trying to do is find some points, and we're finding the easiest points possible. We're letting x and y equal 0. When that's the case, it's just a simple one-step equation. But we're doing a little extra work to get that one-step equation, but that's the goal here. Now, quick note to kind of wrap things up with. Let's go with a different color here. This method won't work that well if we have y equals 4x. Because if we do this, we'll go x and y, and then we'll go 0, 0. And what happens is if we let x equal 0, y equals 0. If y equals 0, x equals 0. And on our graph, we haven't moved away from the origin. So if we wanted to, we could continue to use this method of the table, but pick a different point. So let x equal 1, y is 4. And then what we've done is, we're not really using the intercept method, but we're just finding another easy point to work with here. Now, it could look like this. It could also look like this. Let's just say we have 3x minus 2y is equal to 0. This is very similar to that. It's just in a different form. Again, if we were to make a table, x, y, we would have 0, 0. We'd just find a bunch of zeros. And so we'd have to maybe either use a different method, or we just have to add an extra point. So good luck with your practice, and let me know if you have any questions.